Our first lesson of chapter 3 for geometry. So we are going to start talking about congruent figures here in chapter 3. So the basics here for 3.1 and 3.2 are just about what does it mean for figures to be congruent, and then the idea of corresponding parts when we have congruent figures. And then we're also going to get into ways to prove triangles are congruent. It's very difficult to prove all different types of shapes are congruent. Triangles are pretty much the most basic ones, and you can do the most with them. So that's where we start with just ways to prove triangles congruent. So that's what we're going to get going here in chapter 3. So as a little warm up, just kind of a review. I know that you have heard these words before, congruent and similar. So just wondering if you can identify for each of these pairs of shapes, are they congruent, are they similar, or are they neither? So pause the video and see what you can do. All right, so when I look at these, the first one I noticed down here on the bottom left, my pentagons, and I see that for the pentagons, all the angles are the same measure, right? And all the sides are marked congruent. And so those two shapes are exactly the same size and exactly the same shape, right? So these guys are definitely congruent. All right. Now, my two green triangles up at the top, I don't know anything about the angle measures, but I do see that I have a 3.5 centimeters and a 3.5 centimeters, a 4.5, a 4.5, and a 4 and a 4. And so those all match up, which means like if I took 3 toothpicks that were exactly those lengths, the only way to make that triangle is for it to look exactly the same, right? So these as well are congruent, even though we only know about our side lengths and not about our angle measures. But as we can see, when those two are exactly the same size, then the angles end up being in the same ratio as well, right? All these angles have to be congruent because otherwise my sides wouldn't line up, right? It would leave some gaps if I had a different angle in between those side measurements. So my side lengths there for my triangles were enough to show that the angles would be congruent as well. All right, now in my bottom right here, my other pair of two triangles, I see that all the angles are marked congruent, right? All corresponding angles, I should say, right? They're not all the same measure, but they each have a corresponding congruent pair, right? So all corresponding angles are congruent on this one. But as you can see, triangle DEF is definitely smaller than triangle ABC, right? So even though all the angles are congruent, or all the pairs of angles are congruent, they're definitely different sizes. But they do look similar, right? So these two triangles are similar. They're the same shape, but different sizes. And that's if all I know are the angles. So when I had my green triangles, all I knew were the sides, but the side lengths were enough to hold the angle measures in place. But when all I know is the angle measures, those sides can scale up or down and still be the same angle measure. So that's kind of a good thing to think about as we get into thinking about congruent figures. So what we're going to do right now is we're going to actually write a definition for congruent figures. So as you can see in our warm-up, we talked about congruent when all the corresponding parts were congruent, right? So congruent figures are the same size and the same shape, but in our better words, if two figures are congruent, then all pairs of corresponding parts are congruent. Now this is a definition, right? So we know that this can be reversible, or I could write the converse. If all pairs of corresponding parts are congruent, then the two figures are congruent. So that works. When we say all pairs of corresponding parts, we just mean, I'll put little bullet points here, all corresponding angles are congruent, and that means all corresponding sides are congruent. So that's what we mean when we say corresponding parts. Okay, so when I see my two triangles down here, I see a whole bunch of markings going on, but you can see there I have, side AC is congruent to XY, AB is congruent to YZ, BC is congruent to XZ. Angle A is congruent to angle Y, angle C congruent to angle X, angle B congruent to angle Z based on those markings there. So that's what we mean by corresponding parts. So whichever part from the first triangle is congruent in the second triangle, those we call corresponding, right? Now, when we write down triangles are congruent, order matters. Okay, order matters. So if I was going to write down, hey, these two triangles are congruent, I see that all their corresponding parts are congruent, I have to be very careful, sorry, I'm kind of zooming in and out, about the order that I write the letters in. So if I was going to say triangle ABC is congruent to triangle, well, now I have to be careful. Let's see, what angle does angle A correspond to? Angle A corresponds to angle Y. So Y has to be the first letter because A is the first letter. So angle A congruent to angle Y, right? Now I have to be careful, right? What angle does angle B correspond to? B corresponds to angle Z. So Z has to be my second letter. I'm going to change the color here a little bit. Okay, so angle B corresponds to angle Z, and then angle C, there we go, corresponds to angle X. So I have to make sure that I write them in the correct order. A is first and Y is first, that means those are the corresponding parts. So I have to make sure that the congruent parts line up. Now this also works for segments, and as we wrote on, like that's the only way to write it, but now you can see segments by looking at two letters, right? So the first two letters here was AB, and the first two letters here was YZ. And we notice AB does correspond to YZ because they're congruent. AB, congruent to YZ. Okay, then I can look at the last two letters, BC and ZX. BC, ZX, they're both marked the same. They're congruent, BC, congruent to ZX. And then I could also look at the first and last, right? AC and YX. There's AC, here's YX. AC, congruent to YX. So all those corresponding parts are congruent, and so that's why we have to write them in that order. All right, so a little practice for you. We'll take a look at these two triangles. Do you see two triangles in the picture? I hope that you do. I see a triangle over here on the left, right there, and I see a triangle over here on the right here. So take a look at those two triangles and see if you could write down the order that they should go in for the sides and the angles to be congruent. All right, so when I look at this, I only see two pairs of sides that are marked congruent, right? I see KI is congruent to KE. KI, congruent to KE. And I see down at the bottom here, IT is congruent to ET, right? So I thought I needed more than that. Well, does KT, they both share KT, right? So if I have KT in my yellow triangle and I have KT in my green triangle, will they be the same length? Yeah, because we're talking about the same points, K and T, right? We call this the reflexive property. So if we wanted to say that KT is congruent to KT, it's congruent to itself, this is called the reflexive property. All right, and the idea of the reflexive property, kind of like reflective, like looking in a mirror, right, is that any side or angle is congruent to itself, right? And the only time this is used, only used when we're proving triangles congruent. Now, sometimes the book will throw it in here for some subtraction ideas, but we don't need it for that. We only need it when we're proving triangles congruent to show that we know that that side is congruent to itself, so then I know that those triangles have to be congruent. It'll come back up here in a little bit, but just remember, like if you needed to show that these triangles were congruent, the reflexive property could be used here in a proof like this. Now we saw in our warm-up that when we had all three pairs of sides congruent, that the angles would be congruent as well, right? So we do know that these triangles are congruent because of all the sides. So now if I'm going to write them in the correct order, right? We said that KI corresponded to KE. So KI in the first triangle would correspond to KE in the second triangle, right? And then IT in the first triangle corresponded to ET in the second triangle. So I would have to have triangle KIT congruent to triangle KET. Or, I mean, you could say, maybe I started at I, right? So I could say triangle K is congruent to triangle ETK. And then that would be IT, TK, KI, right? So as long as the order is correct, you can shuffle them around a little bit. There's a few more options, right? But just have to make sure that the corresponding parts are lining up, okay? And the big thing that we learned here is about that reflexive property. So you always know that a segment or angle is congruent to itself. All right, now that last one kind of brought up the idea of how do I prove triangles are congruent? So there are actually 3 ways to prove triangles congruent. Now we looked at that first way both in the last problem and in our warm-up, right? When we have all 3 pairs of sides congruent, we know that those 3 pairs of sides hold the angles congruent as well. So we don't have to do all of those corresponding parts. We don't have to prove that all 6 things, all sides and all angles are congruent. If we just have the 3 pairs of sides congruent, then we'll know that those 2 triangles will be congruent. That means the angles will have to be. So if we know 3 pairs of sides are congruent, then we have congruent triangles. Another option is if we have side, angle, side. Now if I draw my 2 set pairs of triangles here, so this is only 2 pairs of sides that are congruent, but notice we have the word angle in between, right? This angle has to be what we call the included angle, meaning the angle in between the 2 pairs of congruent sides, and it has to be that one. Now think if we knew an angle, side length 3 centimeters for this one slide, for this guy right here, if this was 3 centimeters, and we knew like this one was 4 centimeters, right? So if we had toothpicks that were that length, and I knew exactly that the angle in between them was the same, then this last side would have to be the same length for both of them, right? If you picture 2 pencils, right, that were the same length, and the angle in between them was holding tight, then that side across from it would have to be the same as well. So that's why it has to be the angle in between, right? Now, if we didn't know that angle, but we knew, say, this angle, well, then it could lean and one could be longer, and that wouldn't hold up anymore. Okay, so it's always the included angle, or the angle in between the 2 pairs of congruent sides. Now, our last option here is angle, side, angle. Now, we saw in our warm-up that angle, 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 knowing all 3 angles wasn't enough, because then my triangle could get bigger or smaller, right? But if I know that I have this pair of angles congruent and a second pair of angles congruent, and if I have the side in between them, so again, notice it's in between. Whoops, that's not what I wanted to do. Here we go. This is the included side. So it has to be the side in between those two pairs of congruent angles. Because if I know that this angle is holding this side in place here, and this angle down here is holding this side in place, and I know exactly how far apart they are, then there's only one way for these guys to meet, and that's if these two are the same length as these ones. So that's why it has to be that included side. So our three ways to prove triangles congruent: side, 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 SSS, side, angle, side, SAS, and angle, side, angle, ASA. And you do have to be careful that when you have the two pairs of sides, it's the angle in between them. When you have the two pairs of angles, it's the side in between them, the included side. All right, so a little bit of practice using those new methods. So if you look at each pair of triangles here, decide if you can prove them congruent, and if you can, which one of those three ways would you use? Okay, pause your video and see if you can do this. All right, now on the first pair here, I notice that I have these sides marked congruent, these sides marked congruent, and these sides marked congruent. So that looks like it would be side, side, side. Okay, now on the bottom one, or excuse me, not the bottom one, number 2. Okay, I notice that I have, here's a pair of congruent sides. Here's the second pair of congruent sides. And I do have the angle in between them. Now the only thing is, on the first triangle over here, the 1 dash is on the left and the 2 dashes on the bottom, but on the right hand triangle, the 1 dash is on the right, but the 2 triangles is on the bottom. This is still side, angle, side though, because if you can picture just flipping this guy over, and so that they would kind of be at the same angle, it would probably look something like this, right? I'm just gonna flip it over. This guy will come here, that one goes all the way over, this guy kind of just lands right here. So if you can flip your triangle over and it would line up in the correct order, then it is still congruent. I hope that makes sense. Okay, now on the bottom one, let's see. Oh, I have, okay, this pair of congruent sides, I have this pair of congruent sides, and I have an angle. Side, angle, side. Ooh, not this time, because it's not the included angle, right? It has to be the angle in between the two pairs of congruent sides for it to be side, angle, side. Now, so we would say that this cannot be proven. Now be careful. It could be congruent, right? We don't know what those other 2 angles are, or that third side. Maybe they're congruent, but I don't have enough information to prove it. So we don't necessarily say not congruent. I don't know that, but I can't prove it. I can't use one of these methods. This is not side, angle, side. It's not angle, side, angle, and it's not side, side, side. So I can't prove them congruent. Not enough information. Okay. So just to make sure that you're really solid on using those 3 methods. So here they've given us some information, and we want to know what one other piece of information do we need in order to prove them congruent using the method they say. So in number 1, triangle HGJ and triangle KOM, we're trying to prove congruent by angle, side, angle. What other piece of information would we need? Well, let's see. I see that I have HG congruent to KO, so there's one side. I have angle G congruent to angle O, so there's there's our angle. Now, if I want it to be angle, side, angle, I have an angle, I have a side. I need another pair of angles. And remember that my side has to be the included side, right? So this guy here has to be in between the congruent angles. So that would mean that I would need angle H to be congruent to angle K. And if I knew that, then I would have angle, side, angle. Okay, so then the number 2 here says I need to prove that these 2 triangles are congruent by side, side, side. I see I only have one pair of sides. Oh, wait, or do I? Oh, they share KI, right? And we learned back in a couple slides ago that we could use the reflexive property that this always works. We can always say that a side is congruent to itself. So that technically was given to us by looking at the picture. So with the reflexive property, I know that Ki is congruent to itself. So now I actually have two pairs of sides. So the only pair of sides that I still need are Ji congruent to Ib. All right. So we've talked about how to use those three new methods kind of just by looking at pictures and determining if they're congruent or not, or what do you need to use those methods. Let's actually practice doing it in a proof. So here we have our triangle, and in our triangle we're given MH is congruent to TH. A is the midpoint of segment MT, and we're proving triangle MAH is congruent to triangle TAH. And we're going to be very careful. We have to watch and see that our parts are lining up correctly. All right, so I'm going to start my proof with my givens. Segment MH is congruent to segment TH. Given. Okay, second given is A is the midpoint of segment MT. A is the midpoint. Well, what does that tell me? If A is the midpoint of segment MT, that means that segment MA is congruent to segment AT. And the reason is if a point is a midpoint, whoops, sorry, I was writing too close, then it splits the segment into two congruent parts. So MA is congruent to AT, and it is so very important that you mark your picture on these. Now, I'm hoping you guys are starting to see some options here on what method we might use. I notice I don't have a single angle marked congruent in my picture yet, so I'm thinking angle side angle is probably out. I have two pairs of congruent sides marked, right? So it could be side angle side, or it could be side side side. I don't know anything about angles though. None of my givens say anything about any of these angles, so I'm wondering if it's side, side, side. If it was side, 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 I would need this. Oh, now those, AH is congruent to AH because of the reflexive property, right? So that's what we would need in our proof. This is why we have to have the reflexive property. And all we write for our reason is the reflexive property, and that's it. There's really no way to write that in if-then form, so we just say reflexive property. And now I can see that I have all three pairs of congruent sides are congruent. So all three pairs of corresponding sides, I apologize, are congruent. So I can then say triangle MAH, and I'll notice MAH goes green side to blue side, is congruent to triangle TAH, and that also goes green side to blue side. So our order is okay. And the reason is side, side, side. Now, here's the thing. Since this is not written in if-then form, we want to have a good self-check on if we have all the information we need. Do we really have 3 steps that show congruent sides? So whenever we use any one of these 3 methods, we always put in parentheses 3 numbers. And those 3 numbers are the step numbers of your congruent parts. So step 1, step 3, and step 4 were the corresponding parts that we proved congruent. So in my parentheses, it would say 1, 3, 4. Sorry, it was a little sloppy. Okay, so whenever you use any of those 3 methods, you have to include the 3 numbers of your congruent steps. Okay, for any of the 3 methods, include the congruent step numbers. Right? So side, 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 I have 3 pairs of congruent segments. Those are the ones that go in the parentheses. If I had side, angle, side, 2 of those steps would be congruent segments, 1 step would be congruent angles. If I had angle, side, angle, I would have 2 steps that were congruent angles and 1 step of congruent sides. So we always need to have those congruent steps, those step numbers in the parentheses after we use those letters. All right, I think that's a pretty good introduction here. So just remember, for congruent figures, it means all corresponding parts are congruent, both angles and sides. When stating that figures are congruent, the order matters. Make sure your corresponding parts line up, but also if they tell you that triangles are congruent, and then you can tell which parts are corresponding based on how they write their letters. And then the last one is our 3 ways to prove our triangle is congruent: side, 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 angle, side, and angle, side, angle. And just remember for the last 2 there that included angle or the included side is the side or angle in between the other 2 pairs of congruent parts. And then make sure you list those 3 congruent steps in the parentheses when you use any of these methods in a proof.